Section 2.3, arithmetic operations on matrices. We started matrices already, and we probably jumped into the deep end first because we really never defined what a matrix was. But a matrix is a rectangular array of numbers. Array is a word, it really means arrangement of numbers. I don't know if that's a math term or what, but that's what they use. All the data is arranged in rows and columns. We use these matrices to help organize our data. And what we're going to find out today, or at least in this lesson, is you can actually do things to matrices. There's operations. It's like a whole new algebra of its own. And we're not going to get real deep in it. We're just going to learn the basics. But I guess the end result from your viewpoint would be we're going to put it into matrices, and eventually you can take these matrices and perform the operations on them. And as they become more sophisticated, you can put them in a calculator or a computer and do it from there. So that's what a matrix is. Okay, let's talk about the size of a matrix. The size of a matrix is determined by its dimensions. So, for example, in this matrix that I have here, you'll notice we have two rows. The rows go across. So we got a row here and a row here. And then the columns go up and down. So we have two rows. And we have three columns. So this would be a 2 by 3 matrix. Okay, very simple. Want to look at this one? I see 1, 2, 3, 4. Remember, they go across. Those are the rows. So I got 4 rows. And I've got 2 columns. So it's a 4 by 2 matrix. Okay, and this last big one. Got 1, 2, 3 rows. I got 1, 2, 3, 4, looks like 5 columns. So that is a 3 by 5 column. Now you'll notice I put the little X in there, usually means times, but we just say 3 by 5. We won't multiply those and come up with a number 15 or 8 or 6 on the other ones. We just say a 3 by 5. Okay. So we talked about some operations. Let's look at some operations and see what we come up with. There's 3 main operations, 3 easy operations. And just like in algebra, you can take numbers, you can add, you can subtract, multiply, and so on. Well, we could do the same thing with matrices. Now, on these operations here, at least addition, subtraction, remember, you have to have the same dimensions. So when you look at the matrix up here, that's a 2 by 2, and that's a 2 by 2. So to add 2 matrices, what you're going to do is you find the matrices that correspond to each other. So I'm looking at the upper left entry there and the upper left entry there. And what I see is 2 plus 5. When I go here, the upper right, I see 3 plus 2. The lower left, I got 0 and negative 1. So 0 plus negative 1. So all I'm doing, I'm just adding the corresponding matrices, or the corresponding entries. And then I got 4 plus 8. And then, as you would guess, we would simplify that down. So 2 plus 5 is 7. 3 plus 2 is 5. 0 plus negative 1 is negative 1. And then 4 plus, that was an 8, is 12. That's my answer. Now, as you go on, this you'll probably do in your head. You'll simply look over here and say, okay, I got 2 plus 5 is 7. 3 plus 2 is 5. 0 plus negative 1 is negative 1. And 4 plus 8 is 12. Okay, let's look at subtraction. Same thing here. I'm going to write this step out. Upper left is 2, upper left is 5, so my upper left here is going to be 2. Instead of plus 5, it's going to be minus 5. It's the same matrices, I'm just subtracting this time. So my answer down here is going to be negative 3. Upper left is 3 minus 2. I get 1. 0 minus negative 1 is 1. And 4 minus 8 is negative 4. Okay, next concept is called scalar multiplication. With matrices, there's two different multiplications. There's scalar multiplication, and then there's just regular multiplication. This is the easy one. This is like the distributive property. When you put a 4 out here, you're saying 4 times each number inside here. So I'm going to take 4 times 2. I'm going to take 4 times 3. I'm going to take 4 times